250 feet down, past layers of black water that swallow flashlight beams whole, divers at Florida's Little Salt Spring found a wooden stake sharpened at both ends, driven into the shell of an extinct giant tortoise over 12,000 years ago. Whoever did it left no bones, no camp, no explanation, just a single act preserved in mud and darkness ever since. That's one sinkhole, one clue, one unanswered question out of 22. Florida's prehistoric past hides more of these. Burial mounds packed with objects that shouldn't exist together. Skeletons positioned in ways nobody can explain. Artifacts that predate the tribes we know by thousands of years. Some finds have sat in museum drawers for decades, unexplained and rarely discussed. Others are still being pulled from the swamp. We start below the surface, where the state's strangest story begins. The water at Little Salt Spring is a deep, unnatural blue-green, almost luminous where the sunlight cuts through before vanishing into darkness. On the surface, it looks like any other Florida sinkhole, a quiet, circular pool ringed by pine and palmetto, the kind of place a hiker might pass without a second glance. But descend past the first 30 feet, and the water turns cold, then black. Below 90 feet, divers enter a world untouched by light for thousands of years, where the walls of the flooded cavern hold a record older than most of recorded human history. Little Salt Spring is one of dozens of submerged sinkholes scattered across Florida's limestone bedrock, formed as ancient caves collapsed and filled with water over tens of thousands of years. To geologists, they are simply karst formations, a natural, well-understood process. But to archaeologists, they have become something far stranger, time capsules. Because in these dark, oxygen-poor waters, in the layers of peat and sediment at the bottom, organic material that would rot away in a normal environment has instead been preserved almost perfectly. Wood, bone, even human brain tissue, in one remarkable case from a nearby site. Little Salt Spring has yielded human remains and artifacts dating back over 12,000 years, placing people here not long after the last ice age, hunting animals that no longer exist anywhere on Earth. Among the most puzzling discoveries is a wooden stake, sharpened at both ends, found driven into the shell of an extinct giant tortoise at the bottom of the spring. Radiocarbon dating placed the find at roughly 12,000 years old. The tortoise appears to have been trapped, then killed, in what some researchers interpret as a hunting or ritual act, perhaps both. But no camp, no hearth, no broader settlement has ever been found nearby from that same period. Why would someone travel to the edge of this specific sinkhole, undertake this deliberate act, and leave no other trace behind? Was it an isolated hunt, born of necessity? Or did this place hold a different kind of significance to the people who came here long before it had a name? The mystery deepens as we consider what else these submerged caverns may still be holding. Florida's sinkholes have produced mastodon bones bearing possible tool marks, stone artifacts resting alongside the remains of animals extinct for over 10,000 years, and human remains whose burial, if burial is even the right word, followed no pattern researchers can confidently explain. Some bodies appear to have been placed deliberately in shallow, now submerged ledges. Others were found scattered, raising open questions about whether they were interred with intention, lost accidentally, or deposited by forces we don't yet understand. Mainstream archaeology treats these sites as invaluable, if incomplete, windows into North America's earliest human inhabitants. Evidence gathered carefully, piece by piece, in one of the most physically demanding excavation environments on Earth. But the difficulty of exploring these sites is itself part of the mystery. Cave diving archaeology is slow, dangerous, and expensive, meaning that likely only a fraction of Florida's sinkholes have been thoroughly examined at all. How many similar steaks, similar tortoise shells, similar unexplained scenes remain undisturbed in the sediment of springs that have never been surveyed? Some researchers speculate that entire chapters of early human activity in North America, belief systems, migration patterns, even encounters we can't yet imagine, may be sitting in total darkness, sealed beneath water and time, waiting for the right conditions, the right divers, the right decade of technology to bring them into the light. Little Salt Spring keeps its secrets patiently. It has done so for 12,000 years. What else might be resting in that stillness, in that place where light gives way to dark, and how much of Florida's earliest story is still waiting, quietly, to be found? Among the bones cataloged from Florida's flooded caverns, alongside the tortoise shell, alongside the scattered human remains, are far larger fragments, curved tusks, some over 9 feet long, and molars the size of bread loaves, pulled from the same rivers and sinkholes that hide the state's earliest human traces. These belong to a creature almost impossible to picture, wandering the palmetto flatlands and cypress swamps we know today, the Columbian mammoth, a towering relative of the modern elephant that once called Florida home, standing taller at the shoulder than the ceiling of an average room. For over 10,000 years, mammoths roamed this land in numbers substantial enough that their remains have been found in nearly every major Florida waterway: the Osceola River, the Wassissa, the Santa Fe, often in astonishing concentration. At sites like Wassissa River's Mammoth Cove and the deep sinkholes of the Osceola, researchers have recovered dozens of individual mammoths, their bones sometimes found alongside stone tools, suggesting direct contact, and likely direct conflict, with the same early human populations who left that sharpened stake driven into a tortoise shell not far away. Some of these sites have produced so many bones, from so many individual animals, that early researchers initially assumed they had stumbled upon natural graveyards, places where aging or injured mammoths simply came to die. Later, study would complicate that picture considerably. And yet, sometime between roughly 12,000 and 10,000 years ago, mammoths vanish from Florida's fossil record almost entirely. Not gradually thinning out over millennia, as one might expect from a slow environmental shift, but disappearing within what geologists consider a remarkably narrow window of time. Why would a species that had thrived here for thousands of years, through multiple climate fluctuations, suddenly collapse so completely and so quickly? The most widely accepted explanation is what scientists call the overkill hypothesis, the theory that human hunters, newly arrived and increasingly skilled, hunted mammoths and other North American megafauna to extinction faster than the animals could reproduce. Florida's rivers offer tantalizing support. Stone points found near mammoth remains at several sites, cut marks on some bones suggesting butchery, and the coincidence in timing between the arrival of well-documented human hunting cultures and the mammoth's disappearance. Proponents point out that mammoths, having evolved for millennia without human predators on this continent, may have had little natural wariness of the newcomers, making them, in theory, easier targets than their long experience with other threats might suggest. It's a clean, compelling narrative. One species arrives, another vanishes. But is it truly that simple? Climate itself was changing dramatically during this same window. The end of the last ice age brought rising temperatures, shifting rainfall patterns, and the transformation of Florida's landscape from an open, grassy plain, well-suited to a massive grazing animal, into the wetter, more forested terrain we recognize today. Some researchers argue this environmental shift alone could have doomed the mammoth, shrinking its habitat and food sources faster than the population could adapt, with human hunting acting as a secondary pressure on an already vulnerable species rather than the primary cause of its extinction. Pollen records pulled from Florida's lake sediments do show substantial vegetation changes during this period, offering physical support for at least part of this theory. The debate between these two explanations, human overkill versus climate collapse, has persisted for decades, and Florida's fossil record, rich as it is, has never definitively settled the question. Why not? Shouldn't such an abundance of remains offer a clearer answer? Part of the difficulty lies in the nature of the evidence itself. Many of Florida's most significant mammoth remains were recovered not through controlled excavation, but by recreational divers exploring the state's rivers, meaning the exact context of many finds, the precise layering and association between bones and human artifacts, was often lost before scientists ever had the chance to study it properly. How many crucial details, a tool resting beside a skeleton, a butchery mark now worn smooth by centuries in moving water, vanished before anyone thought to record them. The very rivers that preserved these bones for 10,000 years may have also concealed the details needed to fully explain their end. Then, there are the more speculative threads researchers have occasionally pulled at, the possibility that some undiscovered pathogen, carried perhaps by newly arrived human populations or their accompanying animals, swept through vulnerable megafauna populations already weakened by environmental stress. Similar hyperdisease theories have been proposed for other extinction events across the globe during this same broad period, though direct evidence remains elusive in every case. This idea remains largely unproven, difficult to test given how rarely soft tissue or genetic material survives from this period, and mainstream paleontology treats it as a minor contributing possibility at best, if a possibility at all. Still, the theory persists in academic discussion precisely because no single explanation, hunting, climate, or disease, has ever fully accounted for the totality of what happened here, in such a compressed span of time, across such a wide swath of the Florida Peninsula. Perhaps what makes this mystery endure is not the absence of evidence, but its overwhelming abundance without resolution. Florida's rivers have given us tusks, teeth, footprints, preserved in ancient mud, even, in rare cases, remnants of stomach contents revealing a mammoth's final meal, a fleeting, almost intimate detail from an animal that vanished 10,000 years before anyone thought to ask what it had eaten. And still, after all of it, no consensus exists on precisely why these massive, resilient animals disappeared so suddenly from a landscape they had called home for millennia. Somewhere beneath the tea-colored water of the oscilla, more bones remain uncovered, more fragments of that final chapter still waiting in the silt. Was it the spear, the changing climate, something unseen entirely, or some convergence of all three, arriving together at precisely the wrong moment for a species that had otherwise proven so enduring? The mammoths are gone. The question of what exactly ended them is not. Miles offshore, where the Gulf of Mexico deepens beyond the sight of land, divers have found something that seems to belong nowhere near open water. The remains of an ancient forest, its cypress stumps still rooted in place, standing silently on the seafloor as they have for tens of thousands of years. This is the site now known as the Underwater Cypress Forest off the coast of Alabama and Florida's Panhandle, sometimes called Florida's Ghost Forest, though its full extent stretches beyond any single state line. Discovered initially by fishermen and later confirmed by researchers using sonar and core sampling, the forest sits roughly 60 feet below the surface, several miles from today's coastline. Radiocarbon dating places the trees at over 60,000 years old, meaning this was dry land, a thriving bald cypress ecosystem long before the last ice age reached its peak, back when sea levels were dramatically lower, and Florida's coastline extended far beyond where it sits today, out into what is now open Gulf water. To understand how a forest ends up underwater, one need only look at the broader pattern of Earth's climate history. As glacial ice expanded and contracted over tens of thousands of years, global sea levels rose and fell by well over 300 feet at their most extreme. Florida, low-lying and geologically young, was especially vulnerable to these shifts, its coastline advancing and retreating dramatically as the planet's ice ages came and went. What is unusual, even remarkable about this particular forest, is not that it existed, but how well it survived its own drowning. The wood recovered from the site is so well preserved that researchers have described it as smelling freshly cut when first extracted. Its resin and grain still largely intact after tens of thousands of years submerged beneath sand, mud, and seawater. Cut a cross-section, and the growth rings are still legible, still countable, as if the tree had only just stopped growing. How does organic material endure that long, in an environment that should have broken it down within centuries? The likely answer lies in the specific conditions of its burial. As sea levels rose, the forest appears to have been rapidly covered by sediment, sealing the wood away from the oxygen and organisms that would normally cause it to decay. This kind of preservation, while rare, isn't unprecedented. Similar submerged forests have been documented in other parts of the world, from the coast of Wales to sites in the North Sea, each offering researchers a rare physical anchor in an otherwise abstract climate record. But few offer a window this far back in time, this well-preserved at this scale. Some sections of the site span areas large enough that researchers have described it less as a discrete patch of trees and more as an entire drowned landscape, complete with what appear to be ancient stream channels and root systems still holding their original shape, as though a map of the vanished coastline had simply been paused mid-sentence and left underwater. The mainstream scientific interest here is significant on its own. Cypress rings from trees, this old, offer a rare, tangible record of climate and environmental conditions from a period we know largely through indirect evidence: ice cores, sediment layers, and computer modeling. Studying these trees, ring by ring, gives the researchers something more concrete: an actual physical timeline of rainfall patterns and growing seasons from tens of thousands of years before written history existed anywhere on Earth. But the forest raises quieter, more open-ended questions too. What was this coastline like when the trees were alive? Who, or what, might have walked among them in the millennia before humans are believed to have arrived in North America at all? The site predates the earliest confirmed evidence of human presence in Florida by tens of thousands of years, meaning if anything did witness this forest firsthand, it left no trace we've yet identified. That absence hasn't stopped speculation from creeping into the edges of the conversation. Some researchers and independent investigators have wondered whether other, similarly preserved sites might exist along Florida's now submerged continental shelf, habitable land during the last ice age, when sea levels sat far lower than today, potentially holding not just ancient trees but early evidence of human or pre-human activity we haven't yet found the means to locate. Mainstream archaeology treats this possibility cautiously. While it's true that submerged continental shelves worldwide have occasionally yielded surprising finds, no confirmed evidence of human activity has been recovered from Florida's underwater shelf to date. Still, the shelf itself remains largely unexplored, its vast underwater terrain surveyed only in fragments, a handful of sonar passes, and isolated dives across an area that would take decades to map in full, leaving open the question of what else might be resting in the dark, undisturbed since the waters rose around it. There is something quietly unsettling about a forest that stood in sunlight, grew for centuries, and was slowly swallowed by the sea, only to remain intact, waiting, long after everything that once walked beneath its branches was gone. Divers who visit the site describe a strange stillness there, a sense of moving through a place time seems to have paused rather than erased, where the ordinary rules of decay simply never applied. The trees remain rooted exactly where they grew. The question is what else beneath that same rising water might still be standing, undiscovered, unnamed, and equally patient. Picture the sound first, the low creak of ancient wood settling under sediment, the slow drip of water finding its way through 60 feet of open ocean to land, silently on a forest floor that hasn't felt sunlight in tens of thousands of years. Now imagine that same silence, that same weight of time, pressing down instead on something that once moved, something enormous, slow, and, if the fossil record is to be believed, entirely unafraid. At sites scattered across Florida, from the phosphate mines of the Peace River to the dark, mineral-rich waters of the Oscilla, paleontologists have recovered the remains of one of Ice Age North America's strangest residents, the giant ground sloth. Not the small, tree-dwelling creature familiar from rainforests today, but an animal that, in its largest form, stood roughly the size of a modern elephant, weighing well over a ton, equipped with curved claws nearly a foot long. Florida's fossil record includes several distinct species of these creatures, among them Ermatherium and Megalonyx, both of which roamed the peninsula for tens of thousands of years before disappearing, alongside the mammoths, mastodons, and other megafauna at the close of the last ice age. Some Ermatherium specimens recovered from Florida rank among the most complete of their kind found anywhere in North America, offering researchers a rare, near-total skeletal picture of an animal most people have never even heard existed. The sheer scale of these animals raises an immediate question. How did a creature this large, this slow-moving by most reconstructions, survive for so long in a landscape that also supported large predators, dire wolves, saber-toothed cats, and American lions among them? The mainstream answer points to the sloth's formidable claws and thick bony deposits embedded in its skin called osteoderms, which likely provided a natural armor plating unlike anything most predators could easily penetrate. Combined with its sheer mass, an adult ground sloth may simply have been too large, too well defended, for most Ice Age predators to reliably hunt. A slow giant that had, through sheer physical adaptation, largely engineered itself out of danger. It's a satisfying explanation, but it leaves open an even more pressing question. If these animals were so well protected against natural predators, what finally brought about their extinction? As with the mammoth, the leading theories circle around the same two suspects: human hunting and rapid climate change, though the ground sloth complicates both explanations in interesting ways. Unlike mammoths, whose remains are frequently found alongside clear evidence of human tool use, definitive evidence of sloth hunting in Florida remains comparatively rare. A handful of sites elsewhere in the Americas have produced trackways suggesting humans may have stalked, or at least closely followed, ground sloths, footprints layered directly atop sloth tracks in ancient mud, preserved by remarkable coincidence and later hardened into stone. But no equivalent trackway has been confirmed in Florida itself. Does the absence of such evidence mean it never happened here? Or does it simply reflect how little of Florida's Ice Age landscape has been preserved in a state where footprints could survive at all? Climate change offers its own complications. Ground sloths, unlike mammoths, were browsers rather than grazers, feeding on leaves, shrubs, and woody vegetation rather than open grassland. In theory, this should have made them somewhat more adaptable to Florida's shift from open plains toward denser forest as the Ice Age ended. and yet they vanished in the same tightly compressed window as the mammoth and so many other Ice Age giants, a pattern researchers call the Quaternary Extinction event, a near-simultaneous collapse of dozens of large species across 2 continents, whose precise cause remains one of paleontology's most actively debated questions. Was Florida's sloth population simply swept up in a broader continental catastrophe, too large and interconnected to trace back to any single cause? Or did something specific happen here, in this particular landscape, that we have yet to identify? Some more speculative voices have pointed to isolated, disputed evidence elsewhere in the Americas, suggesting ground sloths may have survived in scattered pockets far longer than the broader extinction date would suggest. Sailors' accounts and indigenous oral traditions from South America have occasionally been cited in this context, though none carry the weight of confirmed scientific evidence. This raises, at least as an open question, whether small remnant populations might once have persisted in Florida's most remote wetlands, long after the species vanished everywhere else. No confirmed evidence supports this for Florida specifically, and mainstream paleontology remains skeptical of any significant post-extinction survival on the mainland. Still, the fossil record here is famously incomplete, pieced together from isolated river finds and mining operations rather than systematic excavation, leaving plenty of unexamined ground, literally, where surprises could still wait. What remains, for now, are the claws, the armored skin fragments, the massive, silent bones themselves, pulled one at a time from rivers that have kept them hidden for millennia, each one catalogued, measured, and set beside the last, slowly assembling a portrait of an animal that no living person has ever seen move. A creature built, seemingly, to endure almost anything, undone, in the end, by something we still cannot fully name. Was it us? Was it the changing world around it? Or was it some combination the fossil record has not yet revealed? The ground sloth's claws remain sharp even now, millennia later, but the answer to what finally stilled them remains as buried as the bones themselves. Among the same predators that never managed to bring down an armored ground sloth, one set of remains stands out for a different reason. Curved canine teeth, nearly 7 inches long, serrated along their edges, pulled from the same Florida rivers that have given up so many of the peninsula's Ice Age secrets. These belong to Smilodon fatalis, the saber-toothed cat, one of the most formidable predators to ever stalk the Florida landscape, and one whose disappearance remains almost as puzzling as its terrifying anatomy. Florida has produced an unusually rich record of Smilodon remains, recovered from sites across the state, from the Peace River to the Sinkholes of the Panhandle. These fossils reveal an animal built less for speed than for ambush and overwhelming force. A heavily muscled body, powerful forelimbs, and those extraordinary canines, likely used to deliver a precise, fatal bite to the throat or underside of large prey once it had been pinned and immobilized. Isotopic analysis of Florida's Smilodon bones suggests a diet centered on large herbivores, quite possibly including young mammoths, ground sloths, and giant bison. Animals we've already seen roaming this same landscape, tens of thousands of years ago, before all of them vanished within a strikingly compressed span of time. That timing is where the real mystery begins. Smilodon disappears from the fossil record in North America roughly around the same window as the mammoths and ground sloths, somewhere between 10,000 and 11,000 years ago. A collapse that swept away not just prey species, but the specialized predators that depended on them. On its surface, this seems to answer itself. Remove the large herbivores a predator depends on, and the predator inevitably follows. But is the explanation really that straightforward? Smilodon was not a picky eater confined to a single prey species. Evidence suggests a broad diet across multiple large mammals, which should, in theory, have offered some resilience against the loss of any one food source. Why, then, did such an adaptable predator collapse so completely, so quickly, alongside the animals it hunted? Some researchers have pointed toward a phenomenon observed in modern, large predators. Even generalist hunters can be pushed to extinction when enough of their preferred prey species disappear simultaneously, especially if that collapse happens faster than the predator can adjust its hunting strategy or shift to smaller, more elusive game. A cat built for taking down massive, slow-moving herbivores may have been poorly suited, physically and behaviorally, to suddenly hunting faster, smaller prey in a rapidly changing landscape. Some paleontologists have also noted that Smilodon's iconic canines, while devastating against large, restrained prey, were relatively fragile compared to the jaws of a modern lion, poorly suited to the kind of fast, thrashing struggle that hunting smaller, more agile animals would have demanded. This would mean Smilodon's extinction wasn't a mystery in isolation, but a direct casualty of the same broader quaternary extinction event that claimed the mammoth and ground sloth, a single ecological collapse rippling outward through an entire food web. And yet, this explanation leaves its own gaps. Some of Florida's Smilodon fossils show evidence of healed injuries, broken bones that mended, signs of animals surviving serious trauma and continuing to hunt successfully afterward, suggesting a level of resilience and adaptability not always reflected in simpler extinction narratives. If these animals could recover from broken limbs and continue thriving, why couldn't the species as a whole adapt to a slower, multi-generational shift in prey availability? Was something else compounding the pressure? Disease, increased competition from other predators, or perhaps direct conflict with the same early human hunters who left evidence of their presence beside so many other Ice Age remains across Florida? Direct evidence of humans hunting Smilodon in Florida remains extremely rare, far rarer than evidence associated with mammoths or even ground sloths. This absence raises its own quiet question. Were early Florida hunters simply avoiding a predator this dangerous, one capable of inflicting the same kind of fatal wounds on a human hunter that it delivered to prey, many times its own size? If so, Smilodon's extinction may be one of the few among Florida's vanished megafauna where humans played a smaller, more indirect role, a predator that outmatched early hunters directly, only to be undone instead by the collapse of the world around it. More speculative theories, circulating largely outside mainstream paleontology, have occasionally suggested that isolated Smilodon populations might have persisted in Florida's most remote, unmapped wetland interiors, slightly longer than the broader extinction date suggests, hidden within terrain that remained difficult to survey well into the modern era. No confirmed fossil evidence supports a later survival date for Florida specifically, and most researchers regard this as unlikely. But Florida's fossil record remains, as we've seen again and again throughout this exploration, frustratingly incomplete, pieced together from isolated river finds rather than systematic, continuous excavation, leaving room for genuine uncertainty about exactly how and precisely when this formidable predator story in Florida finally came to an end. The teeth remain, preserved in silt and shadow, evidence of an animal perfectly designed for a world that no longer exists, a hunter whose entire body was built around a single, devastating advantage that the changing world eventually rendered obsolete. What finally broke that design, the vanishing prey, the changing climate, or pressures we haven't yet identified, is a question these fossils, for now, refuse to fully answer. Long before Smilodon's canines closed on its final kill, another predator had already carved out its place in Florida's Ice Age hierarchy, one whose bones would prove, in their own way, just as revealing about the strange, interconnected collapse of this vanished world. To understand it, we need to step back slightly further in time, to when Florida's plains still teemed with the great herds that sustained not one, but several of the continent's most formidable hunters. Among the most numerous predator remains recovered from Florida's Ice Age deposits are those of the dire wolf, Aenochiondirus, an animal larger and more powerfully built than the modern gray wolf, with a heavier skull, more robust teeth, and a bite force suited to crushing bone. Florida has yielded dire wolf remains from numerous sites, though nowhere in such staggering quantity as the famous La Brea tar pits in California, where thousands of individuals have been recovered, many of them trapped over millennia while scavenging the carcasses of other animals already caught in the asphalt. Florida's dire wolf fossils, scattered across river sites and sinkholes from the panhandle to the peninsula's interior, tell a somewhat quieter story, but no less puzzling one. Dire wolves were pack hunters, likely coordinating in groups to bring down large prey. Species like the ground sloths, giant bison, and young mammoths we've already traced through this same landscape. Their remains are frequently found in close association with these same megafauna, reinforcing a picture of an ecosystem built on interdependence. Massive herbivores supporting a tier of specialized predators, each adapted to a world of abundant, large-bodied prey. And like so many of the animals we've examined, dire wolves vanish from the fossil record in a tightly compressed window at the close of the last ice age, disappearing across virtually all of North America within a few thousand years. A timeline that places their extinction squarely within the same broader quaternary collapse that claimed the mammoth, the ground sloth, and the saber-toothed cat. On its surface, this seems to fit neatly within the pattern we've already traced. Remove the megafauna, and the predators who depended on them inevitably follow. But dire wolves complicate this picture in an intriguing way. Unlike Smilodon, whose specialized hunting anatomy may have limited its ability to adapt to smaller, faster prey, dire wolves were pack hunters, a strategy that, in many predator species, offers considerably more flexibility. Modern wolf packs are capable of shifting between large and small prey depending on availability, adjusting their hunting strategies across generations as ecosystems change. If dire wolves possessed similar behavioral flexibility, why didn't that adaptability allow at least some populations to survive the megafaunal collapse, the way gray wolves, a smaller, more generalist relative, managed to persist and even expand across the same changing landscape? Recent genetic research has added a further layer of complexity to this question. Studies analyzing ancient DNA recovered from dire wolf fossils have revealed that the species was far more evolutionarily distinct from modern gray wolves than researchers had long assumed. Not simply a larger version of the same lineage, but a separate branch that diverged from other wolf-like canines many hundreds of thousands of years earlier, likely evolving in isolation somewhere in the Americas, while gray wolves were still developing elsewhere entirely. This genetic isolation may have limited the dire wolf's capacity for the kind of rapid adaptation, or interbreeding with more adaptable relatives, that helped other canine species weather the same period of dramatic ecological upheaval. Was it this deep evolutionary specialization, rather than diet or hunting strategy alone, that ultimately left dire wolves unable to adjust quickly enough to a transforming world? Florida's dire wolf remains offer few definitive answers to these broader questions, though they do provide something valuable: direct regional evidence of an animal whose story unfolded across a rapidly changing peninsula, from open grassland teeming with prey to the wetter, more forested terrain we associate with Florida today. Some researchers have wondered whether localized environmental pressures, the specific rate of Florida's transformation, distinct from broader continental trends, might have accelerated the wolf's decline in this region even faster than elsewhere. Though isolating a uniquely Floridian cause from the larger extinction event remains extremely difficult given the fragmentary nature of the fossil record here. More speculative voices, largely outside mainstream paleontology, have occasionally suggested that isolated dire wolf populations might have persisted in North America's most remote regions considerably longer than the broader extinction date suggests, pointing to disputed, unconfirmed remains from various sites across the continent. No such evidence has emerged from Florida specifically, and most researchers view these claims with considerable skepticism. Still, given how much of Florida's Ice Age past has been pieced together from isolated, incomplete finds rather than continuous excavation, the question of exactly when, and precisely why, the dire wolf's presence here finally ended remains genuinely open. The howl of the dire wolf, if it resembled its modern relatives at all, would have echoed across a Florida unrecognizable to us today, a landscape of mammoths and giant sloths, sustaining predators built for a world of abundance that would not last. Somewhere in that vanished chorus of calls between pack members coordinating a hunt across open grassland, the last howl eventually went unanswered. What silenced it for good, and whether it fell all at once or faded slowly across generations we haven't yet traced, remains one more thread in this peninsula's still unraveling story. That same question of adaptability, why one predator's flexibility failed to save it while a close relative thrived, echoes again in the story of Florida's largest and least understood Ice Age cat, one that shared the same landscape as the dire wolf, and vanished, by all appearances, into the same silence. Panthera atrox, commonly known as the American lion, was not closely related to the modern African lion despite the shared name, though genetic and morphological studies suggest a relation to today's jaguar lineage instead, one of the many surprising reclassifications that have reshaped our understanding of Ice Age predators in recent decades. Larger than any big cat alive today, the American lion stood roughly 25% bigger than the modern African lion, making it one of the largest felines to have ever existed, with some estimates suggesting an adult male could have weighed close to 900 pounds. Its remains have been recovered from sites across Florida, though considerably less frequently than those of the dire wolf or even Smilodon, a scarcity that has, in itself, become part of the mystery surrounding this animal's place in Florida's Ice Age ecosystem. Unlike Smilodon's specialized ambush and grapple hunting style, or the dire wolf's coordinated pack strategy, the American lion appears, based on comparisons to modern big cats and limited fossil evidence, to have hunted in a manner closer to today's solitary or small group lion behavior, targeting large ungulates like bison and possibly young mammoths across open terrain. This would have placed the American lion in direct ecological competition with both Smilodon and the dire wolf, three formidable predators sharing overlapping territory and, quite possibly, overlapping prey. How did Florida's Ice Age landscape support three apex predators of this scale simultaneously? Modern ecosystems rarely sustain multiple large carnivore species competing for identical prey without some form of niche separation. Different hunting times, different prey preferences, different terrain. Did Florida's American lions carve out a distinct ecological role that allowed coexistence with its more thoroughly documented rivals, or was competition among these three predators itself a contributing factor in the collapse that eventually claimed all of them? The scarcity of American lion fossils in Florida, compared to other regions of North America, adds another layer to this question. Sites like La Brea have produced far more Panthera atrox remains than anywhere in Florida, raising the possibility that the species existed here in smaller numbers, occupied a narrower ecological niche within the state, or simply left behind fossils in locations we haven't yet identified. Florida's fossil record, as we've noted throughout this exploration, depends heavily on rivers, sinkholes, and mining operations rather than systematic excavation, meaning the comparative rarity of American lion remains here may reflect a genuine scarcity, or may simply reflect where and how fossils happen to be preserved and found. Like the dire wolf and Smilodon before it, the American lion disappears from the fossil record within the same tightly compressed window at the close of the last ice age, disappearing alongside the vast herds of megafauna it depended upon. The same broad explanations apply here as elsewhere. The quaternary extinction event, a combination of rapid climate shift and human hunting pressure sweeping away prey populations faster than predators could adjust. And yet the American lion raises its own particular puzzle. As a species with documented ties to more adaptable, still surviving cat lineages elsewhere in the world, why did this particular branch fail to persist in any form, anywhere in North America? When other large cats managed to survive comparable ecological pressures on other continents, some researchers have pointed to competitive exclusion as a compounding factor. The theory that as prey grew scarcer, competition between Florida's three largest predators may have intensified beyond what any single species could sustainably endure, accelerating declines that climate change and human hunting pressure had already set in motion. This remains a plausible, if difficult to directly prove, hypothesis, since fossil evidence rarely preserves behavioral interactions between species directly. Only the physical aftermath left in isolated bones recovered thousands of years later, without any record of the encounters that produced them. More speculative theories, generally regarded with skepticism by mainstream paleontology, have occasionally suggested that scattered unconfirmed reports of large, unidentified cats persisting in remote regions of North America into more recent centuries might represent a far later survival of American lion populations than currently accepted timelines allow. No verified fossil or genetic evidence supports this for Florida, and the vast majority of researchers consider the species firmly extinct by the end of the Ice Age. Still, given how incomplete Florida's own record of this particular predator remains, the full scope of its presence here, how it lived, how it competed, and precisely how and when its story in Florida ended, continues to rest on fragments far sparser than those left behind by its rivals. There is also the matter of what the American lion's rarity in Florida might say about its social structure, a question that remains almost entirely speculative. Modern African lions live in prides, an unusual arrangement among cats that some researchers believe evolved specifically to allow cooperative hunting of large, dangerous prey on open grassland. Did Florida's American lions form similar social groups? And if so, did that behavior offer any advantage or disadvantage compared to the dire wolf's pack structure competing for the same herds? Fossil evidence alone cannot answer questions of social behavior, and without further finds, the American lion's true place within Florida's predator hierarchy remains an outline sketched mostly from inference. 3 apex predators, sharing one collapsing world, vanishing within the same narrow window of time. Coincidence, competition, or consequence of forces still only partly understood? The American lion's bones, fewer and quieter than those of its neighbors, leave that question resting exactly where the fossil record leaves it. Unresolved, waiting somewhere in Florida's rivers for the next find to shift the balance one way or another. Those same Florida rivers, patient keepers of the American lion's scattered bones, have surrendered something else entirely. Teeth unlike any other found in the state's fossil beds, their surfaces studded with blunt, cone-shaped cusps rather than the flat grinding ridges seen in mammoth molars nearby. These belong to the American mastodon, Mammoth americanum, a distant and distinctly different relative of the mammoth, whose story in Florida runs parallel to the giants we've already traced, and ends with a puzzle of its own. Despite the common tendency to lump these two animals together in popular imagination, mastodons and mammoths diverged from a shared ancestor millions of years before, either set foot in Florida, evolving along separate paths shaped by very different diets and habitats. Mastodons were browsers, not grazers, built to strip leaves, twigs, and bark from trees and shrubs rather than graze on open grassland the way mammoths did. This dietary distinction is written directly into their teeth, where mammoth molars evolved flat, ridged surfaces ideal for grinding tough grasses. Mastodon teeth retained a more primitive, cusped structure suited to crushing woody vegetation. Florida's fossil record includes mastodon remains from numerous sites, often recovered from the same rivers and sinkholes that have yielded so much of the peninsula's Ice Age history: the Oscilla, the Wasissa, the Santa Fe, sometimes found in surprisingly close proximity to mammoth remains, despite the two species' markedly different dietary needs. In some cases, researchers have recovered mastodon and mammoth bones from the very same excavation layer, separated by only a few feet of sediment, evidence that both animals were, at times, drinking from and dying near the exact same stretch of ancient water. This overlap raises an immediate question. If mastodons required forested, shrub-heavy terrain, while mammoths depended on open grassland, how did both species thrive simultaneously across the same general region of Ice Age Florida? The most widely accepted answer points to Florida's landscape mosaic during this period, a patchwork environment containing both open plains and forested wetlands in relatively close proximity, allowing specialized browsers and grazers to occupy adjacent, non-competing niches within the same broader ecosystem. It's a reasonable, well-supported explanation. But it also means that as Florida's climate shifted at the close of the Ice Age, mastodons and mammoths would have experienced that change quite differently, one losing its grassland, the other its forest cover, and yet both vanished from the fossil record within a remarkably similar window of time. Why would two species, dependent on entirely different habitats, collapse together rather than at staggered, distinct rates reflecting their different vulnerabilities? Some researchers argue this synchronized disappearance actually strengthens the case for human hunting as the primary driver of megafaunal extinction across Florida, since a species-specific habitat collapse should, in theory, have produced a more staggered decline than what the fossil record actually shows. If mastodons and mammoths vanished at roughly the same time despite requiring different environments, perhaps the common factor wasn't the landscape at all, but a shared vulnerability to increasingly effective human hunters spreading across the peninsula. Florida has, in fact, produced some of the most significant early evidence of mastodon hunting in North America, most notably at the Page-Ladson site along the Oscilla River, where a mastodon tusk bearing possible cut marks was recovered alongside stone tools in sediment layers radiocarbon dated to over 14,000 years ago. If confirmed as genuine evidence of butchery, this would place human presence in Florida and direct human interaction with mastodons specifically, significantly earlier than many long-accepted timelines for human arrival in the Americas. That single tusk, and the broader Page-Ladson site surrounding it, has generated considerable debate within archaeology. Some researchers view the cut marks and associated tool finds as compelling evidence of an unexpectedly early human presence in Florida, one that predates the well-documented Clovis culture long considered North America's earliest widespread human tradition. Others urge caution, noting that natural processes, trampling, gnawing by other animals, or the tusk's own burial and compression over millennia, can sometimes mimic the appearance of deliberate cut marks, making definitive interpretation genuinely difficult even under careful laboratory analysis. The debate remains unresolved, emblematic of a larger challenge running through nearly every mystery we've traced so far. How do we distinguish, with total confidence, between what humans deliberately left behind and what simply happened to bones over 10,000 years of burial, decay, and geological pressure? Subsequent research at the site has attempted to address these concerns directly, using additional dating methods and comparative wear analysis, yet a fully unanimous consensus among archaeologists has still not been reached. If Paige Ladson's evidence holds up under continued scrutiny, it would mean Florida's mastodons weren't simply casualties of a broader continental extinction event unfolding elsewhere, and eventually reaching this peninsula. They may have been among the first and most direct evidence anywhere in North America of humans actively hunting megafauna at the very edge of the last ice age. That would reframe Florida not as a distant corner of a continent-wide collapse, but as one of the places where that collapse may have actually begun. The mastodon's teeth, built for a world of trees and shrubs long since transformed into swamp and marshland, remain scattered through Florida's waterways alongside the tusk that may, or may not, bear humanity's earliest fingerprints on this vanished ecosystem. Was Paige Ladson truly where the story started, or simply where, by chance, the evidence happened to survive long enough for us to find it? Somewhere beneath the same tea-colored water that has already given up so much, the full answer may still be waiting. Consider, for a moment, everything we've traced so far: sinkholes preserving human artifacts beside extinct tortoises, drowned forests standing exactly where they grew. Generation after generation of vanished megafauna pulled one skeleton at a time from the same tea-colored rivers. Nearly every mystery in this collection has, in some way, come back to water. That pattern is not incidental. To understand why Florida's Ice Age past survives in such strange, fragmented pieces, remarkably preserved in some places, entirely absent in others, we need to look directly at the water itself and the catastrophic events that may have shaped it. Florida's modern landscape, with its slow-moving rivers, expansive wetlands, and countless sinkholes, feels almost timeless, as though it has always looked this way. But geological evidence tells a far more turbulent story. As the last ice age drew to a close, and the massive ice sheets covering much of North America began to melt, staggering volumes of freshwater were released across the continent in a relatively short span of geological time. Some of the largest of these events, known to geologists as glacial lake outburst floods, occurred when ice dams holding back enormous glacial lakes suddenly failed, releasing catastrophic volumes of water in a matter of days or weeks rather than centuries. While the most dramatic and well-documented of these floods occurred in the Pacific Northwest, carving the dramatic scablands of eastern Washington in a series of repeated cataclysmic outbursts from ancient glacial Lake Missoula, evidence suggests that Florida experienced its own significant hydrological upheavals during this same broad period, as rising sea levels, shifting water tables, and intense regional flooding events reshaped the peninsula's landscape in ways still being pieced together today. Florida's unique underlying geology makes this story especially complex. The state sits atop a vast limestone platform, riddled with underground caves and channels formed over millions of years of gradual erosion, a process known as karstification. During the Ice Age, as sea levels fluctuated dramatically and freshwater surged unpredictably across the region, this porous limestone foundation would have interacted with those changing water levels in ways far more complicated than a simple rise or fall of the coastline. Some geologists believe that sudden, significant flooding events, combined with fluctuating groundwater levels, may have caused portions of Florida's underground cave systems to collapse rapidly, forming or dramatically enlarging sinkholes across the peninsula within relatively short windows of time, potentially explaining why so many of Florida's most significant Ice Age fossil sites are found specifically within these submerged, cavernous formations, rather than scattered more evenly across the surface. A slow, uniform process of erosion, after all, would be expected to distribute fossil deposits far more evenly across the landscape than what researchers actually find. This raises an intriguing, still unresolved question. Were Florida's countless sinkholes shaped gradually, over tens of thousands of years of slow erosion, as is generally assumed, or did sudden, dramatic flooding events during the Ice Age's final centuries accelerate this process considerably, creating many of the specific caverns and passages divers explore today within a comparatively narrow window of geological time? If the latter is true, it would mean many of Florida's most significant fossil deposits, the mammoth bones, the ground sloth remains, the mastodon tusk at Pageladson, were not simply preserved by these sinkholes over vast stretches of time, but were potentially swept into them, buried rapidly, by the very same catastrophic flooding events that helped carve the caverns themselves. Some researchers have pointed to unusual sediment layering found at several Florida excavation sites as potential evidence supporting this theory. Abrupt transitions in soil composition, suggesting rapid deposition rather than the slow, gradual accumulation typically expected in undisturbed cave environments. Mainstream geology treats this evidence with appropriate caution, noting that sediment disturbance can result from numerous causes beyond catastrophic flooding, including more localized and gradual seasonal flooding patterns, animal activity, or even disturbance from earlier excavation efforts themselves. Still, the question persists precisely because Florida's sinkholes preserve such an unusually rich, concentrated record of Ice Age life. A concentration some researchers believe is difficult to fully explain through gradual processes alone. More speculative theories, existing largely at the fringes of mainstream geological research, have occasionally proposed that Florida may have experienced localized mega-flood events considerably more dramatic and sudden than currently documented mainstream models suggest. Events potentially significant enough to have directly impacted early human populations settling the region during this same turbulent period. No definitive geological evidence has yet confirmed flooding on this dramatic a scale specific to Florida, and most researchers consider current, more gradual models sufficient to explain the available evidence. Proponents of the more dramatic view counter that Florida's flat topography and porous bedrock could have masked or dispersed evidence of sudden flooding in ways that would be far more obvious in a landscape with steeper terrain. But given how much of Florida's underwater terrain remains only partially surveyed, the full scope of what happened here, geologically, during the Ice Age's chaotic final centuries remains an open and actively developing area of research. Beneath Florida's still, quiet waters lies a landscape shaped by forces far more violent than its current tranquility suggests, forces that may have simultaneously destroyed and preserved an entire vanished world in the same catastrophic moment. Were Florida's sinkholes carved slowly across millennia, or violently within a matter of centuries? And if the latter is true, what else, swept into darkness by that same ancient rush of water, still waits to be found? Listen, for a moment, to the sound of water moving over stone. Not the crash of open ocean, but something slower. The quiet suck and release of tide against limestone. The kind of sound that has been repeating itself along Florida's edges for longer than any human memory can hold. It is the same water that once concealed bones, tools, and fires in the sinkholes and rivers explored in the last chapter. But here, the water does something different. Here, it does not preserve. It erases. It rewrites the very shape of the land. To stand on Florida's coast today is to stand on a shoreline in constant negotiation with the sea. a border that has moved, by some estimates, over 300 miles from where it once stood. 300 miles. It is difficult to picture. Imagine walking from present-day Miami almost to Atlanta, and understanding that the entire distance, at the height of the last ice age, was once dry land, grassland, forest, watering holes, and, in all likelihood, human footprints. Around 20,000 years ago, so much of the planet's water was locked into glacial ice that global sea levels sat more than 300 feet lower than they do now. Florida, then, was not the narrow peninsula we recognize on a map. It was nearly twice its current size, a broad plain of savanna and scattered oak hammocks stretching far into what is now the Gulf of Mexico. Mammoths and giant ground sloths would have grazed across land that today lies 50, 80, even 100 feet beneath the waves. And somewhere among them, the earliest Floridians were watching, hunting, surviving, leaving behind a record of their presence that the rising sea would later swallow whole. This is not speculation. Archaeologists have confirmed it directly. At the Page-Ladson site, submerged in the Osceola River, divers have recovered stone tools and butchered mastodon bone dated to over 14,000 years ago, among the oldest confirmed evidence of human presence in the southeastern United States. The site sits underwater now, accessible only to trained divers navigating dark, tannin-stained currents, a reminder that some of Florida's oldest stories were never meant to be read on dry land at all. As the Ice Age ended and the great glaciers began their retreat, the meltwater had to go somewhere. Sea levels rose, not overnight but steadily, sometimes in slow decades-long creeps, sometimes in sudden pulses that geologists still debate the timing of. Coastlines that had stood in one place for 1,000 years might shift inland by a mile within a single human lifetime. For the people living along Florida's ancient shore, this would not have been an abstract climate statistic. It would have been watched, generation after generation, a spring that no longer ran fresh, a hunting ground that grew swampy, a village site abandoned because the water simply would not stop coming. And this is where the mainstream account, solid as it is, begins to open onto harder questions. Because Florida's underlying geology is unlike almost anywhere else in North America. The peninsula sits atop a foundation of porous limestone, karst bedrock, riddled with hidden channels and caverns carved out by acidic groundwater over millions of years. This is why Florida is famous for its sinkholes, and why so many of its rivers seem to appear and disappear without warning, diving underground only to resurface miles away. It is a landscape built on instability, land that can, in a very literal sense, swallow itself. Some researchers argue this karst instability may have accelerated coastal change in ways sea level rise alone cannot fully explain. Sudden collapses, localized flooding events, entire spring systems shifting course within a matter of years rather than centuries. Others have pointed to catastrophic regional flooding, possibly tied to the sudden draining of glacial lakes far to the north, sending pulses of freshwater and sediment down ancient river systems and reshaping the Gulf coastline in ways still not fully mapped. And then there are the artifacts that do not quite fit the tidy timeline. Fishing weights and shell tools recovered from underwater shelves far beyond where scientists expect Paleo-Indian populations to have settled. Anomalous stone formations off the coast near the Florida Keys, visible from the air in the right light at the right depth, that some divers and researchers have suggested resemble deliberate arrangement rather than natural rubble, though rigorous investigation has never definitively confirmed intentional construction. Sonar surveys along the continental shelf have occasionally picked up geometric patterns that spark excitement, and just as often dissolve, on closer inspection, into ordinary limestone outcroppings shaped by millennia of erosion. None of this proves the existence of lost settlements swallowed whole by the rising Gulf. But it does raise a quieter, more patient question. How much of Florida's earliest human history is simply sitting out of reach, not lost to time, but lost to depth? Somewhere beneath the warm, cloudy water off Florida's western coast, entire chapters of a story may be waiting, not hidden by conspiracy or catastrophe, but by the ordinary, relentless patience of the sea. The coastline we see today is not the coastline anyone from the deep past would recognize. It is, in a sense, only the most recent draft, a shoreline still being edited by forces both slow and sudden, both understood and stubbornly unexplained. So the question lingers, as quiet and persistent as the tide itself. What else might still be down there, waiting for someone to look? That same porous limestone, the bedrock riddled with hidden channels and sudden collapses, holds more than water and drowned river valleys. Press your hand into an exposed limestone wall in central Florida, in one of the state's countless quarries or sinkhole faces, and you may find yourself touching something else entirely, the curved, fossilized edge of a shell. Not a seashell. Something far larger, far older, and far stranger. The remains of a tortoise that, in life, could have weighed as much as a grown man, and stood tall enough to look a child in the eye. Florida, it turns out, was once home to giants. The giant land tortoise, Hesperotestudo, roamed the peninsula for millions of years before the arrival of the first humans, and its fossilized remains have been pulled from sinkholes, riverbanks, and quarry walls across the state in extraordinary numbers. Some shells recovered by paleontologists measure well over 2 feet across, a creature that, fully grown, might have rivaled the giant tortoises still found today on isolated island chains like the Galapagos. But Florida is not an island chain. It is a subtropical peninsula that, for most of its geological history, was connected to the rest of North America. Which raises the first quiet question of this mystery. How did such an enormous, slow-moving animal come to dominate this particular landscape, undisturbed for so long? Paleontologists have a reasonably confident answer, at least for the basics. Florida's ancient climate, warmer, wetter, and more stable than much of the surrounding continent for long stretches of the Pleistocene, offered ideal conditions for a cold-blooded reptile that needed year-round warmth to survive. Abundant vegetation, mild winters, and a landscape free of significant large predators for extended periods allowed the giant tortoises to grow undisturbed, generation after generation, into some of the largest land tortoises North America has ever known. Fossil evidence suggests they coexisted, at least for a time, with mammoths, giant sloths, and saber-toothed cats, a landscape almost unrecognizable compared to the palm-lined coastlines tourists picture today. Some specimens found in Florida rival the largest tortoises known anywhere in the fossil record of North America, a detail that continues to draw paleontologists back to the state's quarries decade after decade, searching for the specimen that might finally explain just how large the species grew before its story ended. And then, more than 10,000 years ago, they vanished. This is where the story stops being simple. The giant tortoises of Florida disappeared alongside dozens of other Ice Age megafauna, the mammoths, the mastodons, the giant ground sloths, in what scientists call the late Pleistocene extinction event. The timing lines up roughly, with 2 major changes happening at once. A warming, shifting climate as the last ice age ended, and the arrival of the first human hunters on the Florida peninsula. Both are established, documented forces of change. What remains far less settled is which one mattered more, or whether it was truly one or the other at all. Some researchers argue climate change alone can explain the extinction, pointing to shifts in vegetation and rainfall patterns that would have altered the tortoises' habitat faster than they could adapt. Others point directly to human presence. Butchered tortoiseshell fragments have been recovered at multiple Paleo-Indian sites across Florida, bearing what appear to be cut marks consistent with tool use. Evidence that early Floridians hunted these massive reptiles, at least occasionally, for food. Unlike a fleeing deer or a defensive predator, a tortoise offered no real resistance. No speed to outrun a hunter, no bite or charge capable of deterring one. For a group of early Floridians, equipped with little more than stone tools and patience, a creature that size may have represented weeks of stored meat gathered in a single afternoon, a resource almost too easy to ignore. Did human hunting alone tip an already stressed population into collapse? Or was it simply the final blow to a species already fading under a changing sky? The fossil record, frustratingly, does not offer a clean answer. There is a stranger thread here too, one that drifts toward the outer edges of the mainstream account. A handful of researchers and independent investigators have pointed to isolated, disputed reports, anecdotal, largely unverified, describing unusually large tortoise remains, or tracks, from far more recent centuries, well after the giant tortoise was believed to have gone extinct. A few such claims trace back to early settler journals and local oral histories, describing shell fragments or impressions in mud far larger than anything a modern gopher tortoise could leave behind. No peer-reviewed study has confirmed the survival of Hesperotestudo beyond the Pleistocene, and the overwhelming scientific consensus places its extinction firmly in the deep past. Still, the reports persist in certain circles, treated by most scientists as almost certainly cases of mistaken identity. Perhaps large specimens of Florida's living gopher tortoise, magnified by memory or folklore into something greater. But the persistence of the claims, however unlikely, raises its own quiet question. Why does the idea of the giant tortoise refuse to fully die, even in a form as small as a rumor? What is certain is this. For a span of time difficult to fully comprehend, Florida's forests and wetlands were home to a reptile of astonishing size, one that outlived ice ages and outlasted entire ecosystems, only to disappear at almost the exact moment humans began leaving their own mark on the land. Whether that timing was coincidence, consequence, or something in between remains an open thread in Florida's prehistoric record, one more thread in a landscape already full of them. Somewhere beneath the palmetto scrub and pine flatwoods, more shells almost certainly wait to be found, pressed into limestone, holding whatever answer they still have left to give. The question is only whether anyone will find them in time to ask it. Travel north from those quarry walls and sinkhole shelves, up through the spring-fed rivers of central Florida, toward the limestone caves and riverbanks where another set of bones has waited, undisturbed for longer than most civilizations have existed. Here, in the shadowed banks of the Santa Fe and Ichetuckney rivers, divers and fossil hunters have pulled up something far more unsettling than a tortoise shell. Massive limb bones, skull fragments, and claws belonging to an animal that, if it stood before you today, would tower well over a grown man on its hind legs. This was Arctodus pristinus, the giant short-faced bear, one of the largest land predators to ever walk the North American continent, and, for a stretch of prehistoric time, a resident of Florida itself. To imagine this animal is to imagine something closer to myth than memory. Estimates drawn from fossil remains suggest the giant short-faced bear could stand nearly 12 feet tall on its hind legs, with limbs built for speed rather than the lumbering gait most people associate with bears. Its skull was proportionally shorter and its jaw more powerful than that of modern bears, adaptations that some paleontologists believe point toward a highly carnivorous diet, possibly built around scavenging as much as active hunting. Whatever its exact habits, one thing is clear. For hundreds of thousands of years, This was one of the most formidable predators sharing the Florida landscape with mammoths, giant sloths, and the very tortoises explored in the last chapter. And then, sometime before the end of the Pleistocene, it was gone. The mainstream explanation begins, as it so often does in this era of Florida's past, with climate. As the Ice Age drew to a close, temperatures rose, habitat shifted, and the open grasslands that once supported enormous herds of grazing megafauna began to give way to denser forests and wetter terrain. A predator built for speed across open plains, reliant on abundant large prey, would have found itself increasingly out of step with a changing world. Fewer grazing herds would have meant fewer opportunities to scavenge or hunt, and a body built for size and power rather than adaptability may have struggled to compensate. But climate alone rarely tells the whole story in Florida's prehistoric record, and the short-faced bear's disappearance is no exception. Its extinction lines up closely with the broader collapse of Ice Age megafauna across the Americas, the same wave that claimed the mammoths, the mastodons, and, as explored in the last chapter, the giant tortoises. This convergence raises an uncomfortable question that echoes across nearly every mystery in this series. Was Florida's ecosystem simply too fragile to survive the end of the Ice Age? Or did the arrival of a new, highly capable predator, humankind, tip an already unstable balance past the point of return? Some researchers argue for direct competition. Early human hunters in Florida would have relied on many of the same large herbivores the short-faced bear depended on for scavenged meat. If humans began significantly reducing populations of mammoths, giant sloths, and other megafauna through hunting, the short-faced bear may have found its food sources disappearing at a rate its biology could not accommodate. Others suggest a more indirect pressure, that humans, as a new and unpredictable presence on the landscape, disrupted established predator behavior in ways the fossil record simply cannot capture. Shifts in movement, denning habits, or competition for carcasses that left no physical trace at all. There is also a smaller, stranger detail that continues to draw attention from those willing to look past the mainstream account. A handful of short-faced bear fossils recovered from Florida sites show damage patterns that some researchers have proposed may be consistent with confrontation, rather than natural death or scavenging by other animals. Deep gouges or breaks in bone that raise the possibility, however unconfirmed, of direct conflict with early human hunters. The scientific community remains divided on how to interpret these marks, and no evidence yet definitively proves humans hunted this apex predator rather than simply competing with it from a distance. Still, the question persists: did early Floridians, armed with little more than sharpened stone and numbers, ever face this animal directly? And if they did, what would that encounter have looked like? Played out somewhere along a riverbank now buried beneath centuries of sediment. Beyond the scientific debate lie the quieter, more speculative threads that tend to gather around any vanished giant. Regional folklore in parts of the southeastern United States includes scattered references to enormous bear-like creatures said to roam remote wetlands long after such animals were believed extinct. Stories usually dismissed by researchers as cases of mistaken identity involving Florida's black bear population, magnified through isolation, poor visibility, and the natural human tendency to make the unfamiliar feel larger than it is. No physical evidence has ever supported the survival of Arctodus pristinus beyond the Pleistocene. And yet, much like the giant tortoise, the idea persists at the edges of local memory, refusing to fully disappear from the region's collective imagination. What remains certain is this: for a significant span of prehistoric time, Florida was home to one of the most powerful predators the continent has ever produced, an animal whose disappearance is tied, in ways not yet fully understood, to the same forces reshaping the coastline, the climate, and the very presence of humans on this land. Whether it was climate, competition, conflict, or some combination the fossil record has yet to reveal, the short-faced bear's final years in Florida remain frustratingly out of focus. Somewhere beneath the rivers and sediment of central Florida, more bones almost certainly wait, fragments of an ending still not fully written. What exactly brought this giant down, and how much of that story is still buried, remains an open question. A pattern has begun to emerge in Florida's prehistoric record. A strange and recurring rhythm of giants rising, thriving, and then vanishing within the same narrow window of time. It happened to the tortoises. It happened to the short-faced bear. And it happened too to a creature so armored, so alien in appearance, that early European settlers encountering its fossilized remains struggled to believe it belonged to any animal at all. The Glyptodont, a car-sized relative of the modern armadillo, encased almost entirely in a solid dome of bony shell. To picture a Glyptodont is to picture something that seems to belong more to a paleontological illustration than to the swamps and pinelands of prehistoric Florida. Some species grew to the size of a small automobile, weighing over 1,000 pounds. Their backs covered not in the flexible banded armor of a modern armadillo, but in a single rigid carapace formed from hundreds of fused bony plates. Some species even carried a heavy spiked tail, a weapon capable, researchers believe, of delivering devastating blows to any predator or rival that pressed too close. This was not a small, burrowing creature scuttling along the forest floor. This was a slow-moving fortress, built by evolution to be nearly untouchable. And for a remarkably long stretch of prehistoric time, it was. Glyptodont fossils recovered from Florida's rivers, sinkholes, and phosphate mines reveal a creature that thrived across the peninsula for hundreds of thousands of years, grazing on the same grasslands and low vegetation that sustained the mammoths and giant ground sloths explored in earlier chapters of this series. Its armor, so extraordinary that modern engineers have studied its structure for insights into impact-resistant materials, would have offered protection against nearly every predator native to Ice Age Florida, a defense so effective that few natural threats could hope to crack it. And yet, like so many of Florida's Ice Age giants, the Glyptodont disappeared. The mainstream explanation follows a now familiar shape. As the Pleistocene drew to a close, Florida's climate shifted, its grasslands contracted, and the specific plants Glyptodonts depended on for their low, tough-fibered diet became less abundant across much of the peninsula. A body built for defense rather than adaptability may have struggled to shift its feeding habits quickly enough to survive a rapidly changing landscape. Unlike more mobile species, a creature carrying that much armor would have had limited capacity to migrate long distances in search of new territory, effectively trapping populations in shrinking pockets of suitable habitat as the environment around them transformed. But armor built to withstand claws and jaws offers little defense against a predator that does not need to get close at all. And this is where the Glyptodont story intersects once again with the arrival of early humans in Florida. Archaeological evidence from South America, where Glyptodonts survived somewhat longer than in North America, includes butchered shell fragments, and even evidence suggesting some shells may have been repurposed as shelters by early human groups. A detail that has led some researchers to wonder whether Florida's own Glyptodont populations met a similar fate. If a creature virtually immune to native predators proved vulnerable to coordinated human hunting, fire drives, or trapping methods designed to exploit its limited mobility, the very armor that made it so successful for millennia may have offered little protection against a fundamentally new kind of threat. Direct evidence of human interaction with Glyptodonts in Florida specifically remains sparse compared to South America, and this absence itself has become part of the mystery. Were early Floridians simply less inclined to hunt an animal so heavily armored when other, easier prey was available? Or does the lack of evidence simply reflect how much of Florida's Paleo-Indian archaeological record remains unexcavated, buried beneath sediment, phosphate deposits, and centuries of accumulated wetland growth? Every Glyptodont shell fragment pulled from a Florida riverbed raises the same unanswered question. How many more such encounters, if they happened at all, have simply never been found? At the furthest edges of this mystery lie the same kinds of speculative threads that seem to gather around every vanished Ice Age giant. A small number of researchers have proposed that isolated Glyptodont populations, protected by their swamp habitats from the more rapid ecological changes occurring elsewhere, may have persisted in Florida's most remote wetlands slightly longer than mainstream extinction timelines suggest, a hypothesis that remains unconfirmed by any definitive fossil evidence, but one that continues to circulate among independent researchers drawn to the peninsula's uniquely preserved deep past. No credible evidence points to survival beyond the early Holocene. Still, in a landscape where fossils continue to surface in sinkholes and quarries decades after scientists believed a site fully explored, the question of exactly when the last Glyptodont walked Florida's grasslands remains less settled than most textbooks suggest. What remains certain is only this. For a span of time difficult to fully measure, Florida was home to one of the most armored creatures the natural world has ever produced. A fortress on 4 legs, built to withstand nearly anything, undone in the end by forces that left almost no trace of the moment itself. Climate, hunger, human hands, or some combination the fossil record has yet to reveal, the true cause remains buried, quite literally, beneath the same ground that has already given up so much. Somewhere beneath Florida's phosphate-rich riverbeds, more armor almost certainly waits to be uncovered. What story might the next shell fragment finally tell? Long before the Glyptodonts' armor ever pressed itself into Florida's riverbeds, and long before the earliest human hunters set foot on the peninsula at all, a very different kind of animal moved across its ancient plains, one whose presence here still surprises most people encountering it for the first time. Because for a stretch of prehistoric time spanning millions of years, Florida was home to camels. Not the camels of desert caravans and Middle Eastern trade routes, but their evolutionary ancestors and relatives, slender, long-legged animals that, fossil evidence confirms, actually originated in North America before eventually migrating outward across land bridges toward Asia, Africa, and South America. Florida's fossil record includes remains from several distinct camel species, ranging from smaller gazelle-like forms to camelops, a larger, more familiar-looking relative that would have stood comparable in size to a modern dromedary. Their bones have surfaced in phosphate mines, riverbeds, and sinkholes across the state, sometimes alongside the very mammoths, giant sloths, and glyptodonts already explored in this series, a reminder that Florida's Ice Age landscape supported an extraordinary range of large mammals, most of which modern visitors to the state would never think to associate with its subtropical wetlands. Picture it for a moment. Herds of long-legged camels moving across open Florida grassland, grazing alongside mammoths in a climate radically different from the humid, densely vegetated peninsula tourists recognize today. It is a striking image, and an accurate one, confirmed repeatedly by fossil deposits stretching back millions of years into the Pliocene and Pleistocene epochs. For most of that time, Florida's camels appear to have thrived, adapting alongside a changing climate and shifting landscape with the same resilience shown by many of the era's other large herbivores. And then, like so much of Florida's Ice Age megafauna, they disappeared, vanishing sometime around the end of the Pleistocene, within the same narrow window that claimed the mammoths, the giant sloths, and the glyptodonts already explored in this series. The mainstream explanation follows a pattern that by now should feel familiar. As the last ice age ended, Florida's climate warmed, and its landscape shifted from open grassland toward the denser forests and wetlands more characteristic of the region today. Camels, having evolved for life on open plains, would have found their preferred grazing habitat steadily shrinking, replaced by vegetation less suited to their particular feeding strategy. Combined with pressure from early human hunters, who left behind scattered evidence of interaction with North American camel species at sites across the continent, the story appears, on its surface, relatively straightforward. A habitat specialist, unable to adapt quickly enough to a transformed environment, pushed toward extinction by the same forces reshaping so much of Ice Age Florida at once. But the deeper one looks into the camel's disappearance, the more that straightforward story begins to raise its own quiet complications. Unlike some of Florida's other Ice Age giants, direct evidence of human hunting specifically targeting camels within the state remains notably sparse. Butchered camel bone has been documented at sites elsewhere in North America. Cut marks along limb bones, processed remains found near hearths and tool scatters, but Florida's own fossil record offers comparatively little to confirm how, or how often, early Floridians interacted with these animals directly. Was this simply a gap in the archaeological record, the product of sites not yet excavated or preserved under conditions unfavorable to fossilization? Or does it suggest camels disappeared from the Florida peninsula through a process less directly tied to human hunting than some of the other extinctions explored in this series, perhaps driven more heavily by habitat loss and climate alone? There's a further complication buried within the fossil timeline itself. Some radiocarbon analyses of North American camel remains, though not always specific to Florida, have produced dates that sit somewhat later than researchers initially expected, suggesting isolated populations may have persisted in certain regions longer than the standard extinction narrative assumes. A few such results have prompted quiet debate within the paleontological community, with some scientists questioning whether contamination or mineral saturation in the samples may have skewed the dating, and others treating the anomalies as genuine evidence worth pursuing further. Whether similar late-surviving populations existed anywhere within Florida's own borders remains an open, largely unresolved question, one complicated by the technical challenges of dating fossils recovered from Florida's waterlogged, mineral-rich environments, where preservation conditions can sometimes distort or obscure precise timing. At the outer edges of this mystery, as with so many of Florida's vanished giants, a handful of independent researchers have proposed that pockets of camel populations may have survived in more isolated, resource-rich areas of the peninsula slightly longer than mainstream timelines suggest, sheltered temporarily from the broader ecological collapse occurring elsewhere. No confirmed fossil evidence currently supports survival beyond the accepted extinction window, and the majority of the scientific community regards the standard timeline as well established. Still, the persistent uncertainty surrounding exact extinction dates leaves just enough room for the question to remain quietly, respectfully open. What is certain is this: Florida's landscape once supported animals modern visitors would never expect to find here, evidence of a deep past far stranger and more varied than the palm trees and wetlands suggest today. The camel's disappearance, like so many extinctions explored in this series, sits at the intersection of climate, competition, and human presence, three forces so deeply intertwined in Florida's Ice Age record that separating their individual influence may never be fully possible. Somewhere beneath Florida's phosphate deposits and ancient riverbeds, more bones almost certainly remain, holding fragments of a story still not entirely told. How much of that story might still be waiting, quietly, to be uncovered? Those same ancient riverbeds, the ones that gave up camel bone, glyptodont armor, and the fossilized ghosts of a dozen vanished giants, were not always where they are now. Long before any of those bones settled into sediment, the rivers carrying them followed entirely different paths across the Florida peninsula, paths that modern maps do not show, and modern rivers no longer follow. Florida today is a state defined by its waterways, the winding Suwannee, the spring-fed Ichetucknee, the slow, dark, tannin waters of the Santa Fe. But beneath the current network of rivers and streams lies something far stranger. The traces of an older hydrological system, one shaped by a landscape and climate radically different from anything alive today would recognize. Geologists studying Florida's underlying limestone have identified what appear to be buried river channels, ancient waterways, now filled with sediment, running in directions the current landscape gives no hint of, carved during a time when Florida's coastline sat over 100 miles further out into the Gulf of Mexico. The evidence for these lost rivers comes from multiple independent sources, which is part of what makes the mystery so compelling rather than merely speculative. Sonar and ground-penetrating radar surveys conducted across parts of the Florida peninsula have revealed channel-like formations buried beneath the modern surface, some running for dozens of miles before disappearing beneath layers of more recent sediment. Sediment cores pulled from these buried channels contain material inconsistent with the surrounding limestone, freshwater deposits that could only have accumulated through sustained river flow at a time before the current landscape took its present shape. In some cases, researchers have found buried channels that seem to align, at least partially, with underwater features detected far out on the continental shelf, dozens of miles beyond the current coastline. Submerged valleys and channel-like depressions that some geologists interpret as the drowned extensions of these same paleo-rivers, continuing their course across what would have been open plain during the Ice Age, and is now covered by more than 100 feet of open Gulf water. Mapping that connection fully would require survey work far more extensive than anything conducted to date, but the fragments already recovered hint at a river system considerably larger and considerably older than the one visible on any modern map. Why did these rivers disappear, and why did entirely new ones take their place? The mainstream explanation ties directly to the same forces already explored earlier in this series. As glacial ice melted and sea levels rose dramatically at the end of the Pleistocene, the water table across the Florida peninsula rose along with it. Rivers that had carved their paths across a much larger, drier landscape found themselves partially drowned, their lower reaches submerged beneath rising groundwater and encroaching seawater. Karst collapse, the same porous limestone instability responsible for Florida's famous sinkholes, likely played its own role, redirecting underground water flow and, in some cases, causing surface rivers to disappear entirely into subterranean channels, only to resurface, if at all, somewhere entirely different. This alone would be a remarkable geological story. But the presence of ancient human activity along some of these buried channels adds a deeper, more haunting layer to the mystery. Archaeological surveys near several suspected paleo river paths have recovered scattered stone tools and worked flint, artifacts consistent with early human presence, positioned in locations that would have made little practical sense along the river's modern courses, but perfect sense along a river channel that existed thousands of years earlier. This raises a genuinely open question that current science has not fully resolved. how many Paleo-Indian sites, campgrounds, and hunting grounds were built along rivers that no longer exist in any form visible today, waiting beneath feet of accumulated sediment for someone to notice the channel was ever there at all. Some researchers have taken this question further, proposing that entire early settlement patterns across ancient Florida may need to be reconsidered once buried river systems are more fully mapped. If early Floridians, like nearly every human population throughout history, settled preferentially along reliable water sources, then the true density and distribution of Paleo-Indian activity across the peninsula may currently be badly underestimated, simply because archaeologists have been searching along the wrong rivers. Some have gone further still, suggesting that clusters of undiscovered sites may exist precisely where no modern water source hints at their presence, hidden not by depth or distance but by nothing more than the absence of a river that no longer flows. It is a compelling hypothesis, though still far from proven, and one that would require far more extensive underground and underwater survey work than has currently been conducted across the state. At the furthest edges of speculation, a small number of independent researchers and enthusiasts have suggested that some of Florida's buried river channels may preserve far more than sediment and scattered tools, pointing to sonar anomalies near certain channel paths that some interpret as possible structural remains, though no formal excavation has confirmed any such claim, and most such anomalies, when investigated, resolve into natural limestone formations shaped by millennia of water flow. The scientific consensus remains cautious, and rightly so. Still, the underlying question refuses to fully close. How much of Florida's earliest human landscape is not lost to time at all, but simply buried, waiting beneath rivers that have long since forgotten their own former paths? Somewhere beneath the modern rivers, Florida's residents cross every day without a second thought. Older waterways continue to lie in silence, carrying whatever secrets they were never given the chance to reveal. What might still be found, if anyone finally traced them to their source? Consider, for a moment, everything this series has uncovered so far: vanished rivers, drowned coastlines, giants that disappeared within the same narrow window of time. It would be easy to assume water was always Florida's defining feature, the one constant running through every chapter of its ancient story. But the deep past holds a harder truth. For extended periods, water itself became the very thing prehistoric Florida could not depend on at all. Sinkholes across the Florida peninsula, the same karst formations responsible for so many of the fossil discoveries explored throughout this series, preserve more than bones. Buried within their sediment layers, geologists have identified evidence of prolonged, severe drought periods stretching across Florida's ancient past, some persisting not for a single dry season but for centuries at a time. These were not the seasonal dry spells modern Floridians are accustomed to. These were mega-droughts, climatic events severe enough to fundamentally reshape the landscape, the water table, and the very animals capable of surviving on the peninsula at all. The evidence for these prolonged droughts comes largely from sediment cores extracted from lake beds, sinkholes, and wetland deposits across the state. Layers of exposed, oxidized soil that had clearly been dry and sunbaked for extended stretches before later becoming submerged again, appear repeatedly throughout Florida's geological record, particularly during certain stretches of the Pleistocene and early Holocene. Some of these dry layers span what researchers estimate to be centuries of reduced rainfall, periods during which many of Florida's now abundant springs and wetlands would have shrunk dramatically, or vanished from the landscape entirely. What could cause a subtropical peninsula, surrounded almost entirely by water, to experience such severe and prolonged aridity? The mainstream explanation points to broader shifts in global and regional climate patterns, particularly changes in atmospheric circulation tied to the retreat and advance of glacial ice far to the north. As ice sheets expanded and contracted, they altered wind patterns, ocean currents, and precipitation cycles across the entire North American continent, and Florida, despite its coastal position, was not immune to these far-reaching effects. Shifts in the position of the jet stream, changes in Gulf Stream behavior, and fluctuations in sea surface temperatures across the Gulf of Mexico have all been proposed as contributing factors, each capable of redirecting the moisture that Florida's ecosystems depended on toward entirely different parts of the continent. This explanation is well supported, but it leaves an uncomfortable question hanging over everything else explored in this series. Because Florida's mega-droughts appear to overlap, at least in part, with several of the extinction events already discussed: the disappearance of the giant tortoises, the short-faced bear, the Glyptodonts, and the camels, each vanishing within a window of time that also saw the peninsula's water sources under severe, sustained stress. Were these prolonged droughts a hidden thread running beneath every extinction explored so far, a slow, dry pressure compounding the effects of climate warming and human hunting already discussed? Or did each species face its own distinct combination of forces, with the droughts simply one more variable among many, difficult to isolate from the broader chaos of a transforming Ice Age landscape? There is a particularly striking detail buried within some of Florida's drought-era sediment layers: dense concentrations of animal bone, clustered tightly around what would have been the last remaining watering holes during the driest periods. These bone beds, sometimes containing the remains of multiple species pressed closely together, paint a haunting picture of desperation, animals of every kind converging on shrinking pools of water as the surrounding landscape dried out around them. Some researchers believe these sites may represent some of the clearest physical evidence available anywhere for how severely these ancient droughts reshaped animal behavior, forcing predator and prey into uneasy, temporary proximity around the last available resource. Whether early human populations also concentrated around these same shrinking water sources, and what that might have meant for encounters between hunters and increasingly desperate megafauna, remains an area current research has only begun to explore. Beyond the documented sediment evidence lies a more speculative thread that continues to circulate among independent researchers studying Florida's ancient climate. A small number have proposed that certain drought periods may have been more abrupt and severe than current models suggest, potentially triggered or intensified by localized events, shifts in regional vegetation cover, changes in fire frequency across the peninsula, or feedback loops within Florida's unique karst hydrology that current climate reconstructions may not fully capture. This remains a minority position within the scientific community, and the dominant models continue to attribute Florida's ancient droughts primarily to large-scale, well-documented climate mechanisms. Still, the sediment record itself continues to produce occasional layers that resist easy explanation, apparent drought signatures that do not align cleanly with the broader climate timeline researchers have constructed, leaving small, persistent gaps in an otherwise well-supported story. What remains clear is this: Florida's deep past was defined not only by abundance, but by absence, by long, dry centuries capable of reshaping an entire ecosystem, testing the survival of giants and early humans alike. Water, so often taken for granted in a landscape now defined by rivers, springs, and wetlands, was once the peninsula's most fragile resource, and its disappearance may have quietly shaped far more of Florida's prehistoric story than the fossil record alone can fully reveal. Somewhere within the layers of sediment still waiting to be studied, the full extent of these ancient droughts remains only partially understood. how much of Florida's deep history was written not by water, but by its absence. Travel now to the rolling terrain of Central Florida's Lake District, where hundreds of lakes still dot the landscape today, formed within sinkholes and shallow depressions carved into the peninsula's limestone foundation. Many of these lakes look permanent, timeless even, ringed by cypress and moss-draped oak as though they have always been exactly where they are now. But scattered across this same region lie the telltale remnants of lakes that no longer exist at all. Dry basins, ancient shorelines stranded far from any current body of water, and sediment layers that tell of freshwater systems that once thrived here, and then, for reasons not yet fully understood, disappeared. Florida's Lake District sits atop the same porous karst limestone responsible for so much of the peninsula's unstable, ever-shifting geology already explored throughout this series. Many of the region's lakes are what geologists call solution lakes, formed when the limestone beneath the surface slowly dissolves, creating a depression that fills with rainwater and groundwater. These lakes can persist for thousands of years, stable fixtures of the landscape, sustaining their own ecosystems and, in some cases, entire chapters of prehistoric human activity along their shores. But that same limestone foundation that creates these lakes can also, under the right conditions, take them away. Sediment cores extracted from several central Florida lake basins reveal something striking. Distinct layers marking periods when a lake, once full and thriving, appears to have drained away almost entirely, leaving behind an exposed, sun-baked basin before eventually refilling, sometimes centuries later. In certain locations, researchers have identified what are effectively fossil lakes, ancient basins clearly shaped by long-term water presence that today hold no water at all, their outlines visible only through subtle changes in vegetation, soil composition, or shallow depressions barely noticeable to anyone walking across them without knowing what to look for. The mainstream explanation for these vanishing lakes centers on the same karst instability responsible for Florida's sinkholes and buried rivers already discussed in this series. Because Florida's limestone bedrock is riddled with hidden channels and voids, a lake's connection to the underlying water table can shift over time, sometimes gradually, sometimes with startling speed. A change in regional groundwater levels, a new sinkhole opening beneath a lake bed, or a shift in the underground flow paths connecting a lake to Florida's aquifer system can cause a lake to drain away almost entirely, its water essentially disappearing downward into the very ground that once held it in place. Combined with the mega-droughts explored in the previous chapter, this creates a landscape where lakes were never truly permanent fixtures at all, but temporary arrangements between surface water and the restless limestone beneath it. This explanation accounts for much of what the sediment record shows, but it does not fully explain everything researchers have found along the shores of some of these vanished lake basins. Archaeological surveys near several dry ancient lake beds have recovered concentrations of stone tools, shell middens, and other evidence of sustained human activity. Settlements that appear to have been built directly along what would have been a thriving lake shore, only for that lake to eventually vanish beneath them, leaving human occupation sites stranded in what is now dry, unremarkable terrain. This raises a genuinely open question. Did the disappearance of these lakes happen gradually enough for the people living beside them to relocate in time, following the retreating waterline as generations passed? Or did some lakes drain more suddenly than the geological record can currently distinguish, leaving behind communities that had built their entire way of life around a water source that, within a single lifetime, simply ceased to exist? There is a further complication that continues to intrigue researchers studying this particular corner of Florida's prehistoric puzzle. A small number of the dry lake basins examined so far contain sediment layers suggesting extremely rapid drainage events, rather than the slow, gradual decline more consistent with drought alone. Some geologists have proposed sudden karst collapse as the most likely explanation, a swift opening of underground channels capable of draining a lake far faster than evaporation or reduced rainfall ever could. Others remain more cautious, noting that distinguishing rapid drainage from slow decline within ancient sediment layers is technically difficult, and that more detailed core sampling would be needed before drawing firm conclusions about exactly how quickly any particular lake vanished. At the outer edges of this mystery, a handful of independent researchers have proposed that certain of these dry lake basins may hold more than sediment and scattered artifacts, pointing to unusual soil discoloration patterns or subsurface anomalies detected in preliminary surveys that some interpret as possible evidence of structures or features not yet formally excavated. No confirmed archaeological findings currently support these more speculative claims, and most researchers attribute such anomalies to natural variation within the karst landscape itself. Still, Central Florida's dry lake basins remain, by most accounts, among the least systematically studied landscapes in the state's prehistoric record, simply because they no longer look to the casual observer like anything worth investigating at all. What is certain is that Florida's Lake District was never as stable as it appears today, its familiar, permanent-seeming waters resting atop a foundation capable of quietly taking them away. Somewhere beneath the dry basins and stranded shorelines still scattered across central Florida, the full story of what happened and when and to whom remains only partially written. What might still be resting in the sediment of a lake that no longer exists? The same early Floridians who built their settlements along the shores of lakes that would later vanish beneath them were not living in isolation. They shared this landscape with a wide range of Ice Age animals, and among the most surprising to modern visitors unfamiliar with Florida's deep past was one whose bones lie scattered throughout the very sediment layers already explored in this series: the horse. Long before Spanish explorers reintroduced horses to the Americas in the 16th century, Florida was already home to native horse populations, evolutionary descendants of the same lineage that gave rise to the modern horse, a lineage that, remarkably, originated in North America millions of years before, spreading to Asia and eventually the rest of the world. Fossil remains from several distinct prehistoric horse species have been recovered across Florida, from phosphate mines and river bottoms to the same lake basins and sinkholes that have already yielded evidence of camels, giant tortoises, and glyptodonts throughout this series. Some of these ancient horses were quite different from the animals recognized today. Smaller in stature, with subtle variations in limb and hoof structure, suited to Florida's shifting Ice Age terrain. Others were remarkably similar in size and build to modern horses, grazing across the same open grasslands that once supported so much of Florida's vanished megafauna. For an extraordinarily long stretch of time, these native horses thrived here, adapting alongside the peninsula's shifting climate and landscape, much as many of its other large herbivores did. And then, like the camels, the giant tortoises, and so many other species already explored in this series, they disappeared, vanishing from the Florida peninsula, and indeed from the entirety of the Americas, sometime around the end of the Pleistocene. This particular extinction carries a weight the others do not quite share because of what came after. Horses, having evolved in North America and having gone extinct here entirely, only returned to the continent thousands of years later, brought back across the Atlantic by European colonizers. For roughly 10,000 years, a landscape that had once been home to native horse populations for millions of years had none at all, an absence so complete that by the time horses reappeared on Florida soil, no living memory, human or otherwise, remained of what had come before. The mainstream explanation for the horses' disappearance follows a familiar pattern by this point in the series. Climate change at the close of the Pleistocene altered Florida's grasslands, shrinking the open terrain horses depended on for grazing and replacing it with the denser forests and wetlands more typical of the region today. Combined with pressure from early human hunters who left behind archaeological evidence of horse hunting at sites across North America, the standard extinction narrative suggests a familiar convergence of environmental stress and human predation, occurring within the same narrow window that claimed so many of Florida's other Ice Age giants. But the horse's extinction raises its own distinct and difficult question, one that continues to occupy researchers studying the broader collapse of North American megafauna. Horses were remarkably adaptable animals, capable of thriving across an enormous range of environments, from open grassland to more mixed terrain, and had already survived multiple earlier periods of significant climate change over their long evolutionary history in North America. Why, then, did this particular period of change prove insurmountable when horses had weathered so many previous transitions? Was human hunting pressure simply more severe or more sustained than the pressure applied to less adaptable species? Or did some combination of factors specific to this particular climate transition, the speed of the change, rather than its severity alone, overwhelm even an animal built for resilience? Some researchers have proposed that the specific pattern of human expansion across the Americas may hold part of the answer. Unlike some of Florida's other extinct megafauna, horses were present across nearly the entire North American continent, and their extinction appears to have occurred in remarkably close alignment with the rapid spread of human populations across the same territory. This overlap has fueled ongoing debate about whether human hunting alone could have driven a species this widespread and adaptable to complete extinction across such a vast range, in a period of time that, on a geological scale, amounts to little more than an instant. At the more speculative edges of this mystery, a small number of researchers have questioned whether isolated horse populations might have persisted in certain refuges longer than the standard extinction timeline suggests, protected temporarily by geography or local climate conditions from the broader pressures affecting the species elsewhere. No confirmed fossil evidence currently supports horse survival in Florida beyond the accepted extinction window, and the mainstream timeline remains well established within the scientific community. Still, the sheer improbability of the horse's story, a species born in North America, driven to extinction on the very continent that created it, only to be reintroduced by outsiders millennia later, continues to draw researchers back to the question of exactly what happened during those final, poorly documented centuries. What is certain is that Florida's grasslands once thundered with the presence of an animal whose absence would define an entire continent for 10,000 years, until history returned it by an entirely different path. Somewhere in the layers of sediment still being studied across the state, the final chapter of that original disappearance remains only partially told. What might still explain why the horse's first chapter in Florida came to such a complete and lasting end? That question raised in the last chapter, whether it was the speed of change, rather than its severity alone, that overwhelmed even Florida's most resilient species, sits at the very center of one of the deepest mysteries in this entire series. Because when researchers examine exactly how quickly Florida's Ice Age climate actually shifted, the numbers themselves become difficult to reconcile with the slow, gradual transition at all. For decades, the standard understanding of the end of the last Ice Age described a relatively gradual warming trend, unfolding across thousands of years as glacial ice retreated northward, and the planet settled into the warmer, more stable climate that has persisted through most of human civilization. And in broad strokes, this remains true, But buried within Florida's own geological record, in sediment cores, pollen deposits, and isotope analysis pulled from lake beds and sinkholes across the state, lies evidence of something stranger. Periods when Florida's climate appears to have shifted not over millennia, but within a span of decades, sometimes even less. Pollen records extracted from Central Florida's lake sediments, the very lakes explored 2 chapters ago, reveal abrupt transitions between distinct plant communities, shifts from one dominant vegetation type to an entirely different one occurring within sediment layers thin enough to represent a remarkably short window of time. Similar patterns appear in isotope data drawn from cave formations and groundwater deposits across the state, chemical signatures capable of recording ancient temperature and rainfall patterns with striking precision. Together, this evidence points toward a climate system that did not simply warm steadily as the Ice Age ended, but lurched at certain points with a speed that modern climate science is still working to fully explain. The mainstream explanation for these rapid shifts centers on what scientists call abrupt climate change events, sudden reorganizations of global ocean and atmospheric circulation patterns that have been documented at multiple points throughout the Pleistocene's final millennia. The most well-known of these, an event known as the Younger Dryas, saw much of the northern hemisphere plunge back into near-glacial conditions for roughly 1,000 years, before climate rapidly warmed again at its conclusion, with some ice core records suggesting temperature shifts on the order of several degrees occurring within mere decades, and in a few especially dramatic layers, within years rather than decades at all. Researchers studying Greenland ice cores have documented similarly abrupt transitions elsewhere in the geological record, lending broader credibility to the idea that Earth's climate system is capable of shifting states far more quickly than the gradual warming narrative typically presented to the public would suggest. Florida's own sediment record appears to preserve echoes of this same abrupt transition, along with what may be other, less well-documented rapid shifts specific to the region, some of which do not yet have a clear counterpart in the broader North American climate record. What causes such sudden reorganizations of global climate remains one of the more actively debated questions in paleoclimatology, and Florida's own geological record has become an unlikely but valuable piece of that broader scientific puzzle. The leading explanation involves massive pulses of glacial meltwater draining suddenly into the North Atlantic Ocean, disrupting the ocean circulation patterns responsible for distributing heat around the globe. When this circulation system falters, regions dependent on its warming influence can experience rapid, dramatic cooling, even as the planet as a whole continues its long-term warming trend. Florida, positioned near the edge of these disrupted circulation patterns, may have experienced the resulting instability more acutely than researchers initially assumed, its subtropical climate whipsawing between distinct states in a manner far more volatile than the peninsula's current stability would suggest. This explanation accounts for much of the abrupt climate signature Florida's sediment record preserves, but it leaves unresolved exactly how such volatility might have compounded everything else already explored throughout this series: the Mega-Droughts, the vanishing lakes, the extinction of the tortoises, the bears, the Glyptodonts, the camels, and the horses, each occurring within a period now increasingly understood to have been far less climatically stable than previously believed. Did Florida's Ice Age megafauna face not a single gradual environmental decline, but a series of increasingly unpredictable climate whiplashes, each one testing species already weakened by the last? And if the climate itself was behaving this erratically, how much of what happened to Florida's earliest human populations during this same window remains fundamentally misunderstood, framed by a timeline that assumes a stability the evidence increasingly suggests never truly existed? At the outer edges of current research, a number of scientists have begun questioning whether Florida's unique karst hydrology may have amplified these abrupt climate shifts beyond what occurred in less geologically unstable regions. The same porous limestone responsible for the peninsula's vanishing rivers and lakes, potentially accelerating how quickly local water systems responded to broader climate volatility and possibly intensifying, on a purely regional scale, effects that elsewhere unfolded more gradually. This remains an active and unsettled area of study, with sediment records from different parts of the state occasionally producing conflicting signals about the precise timing and severity of specific climate events, gaps that current research has not yet fully reconciled. What is becoming increasingly clear is this: the story of Florida's ice age was never one of slow, predictable transition, but of a climate system capable of turning, with startling speed against every species that had built its survival around the assumption of stability. Somewhere within the sediment layers still being analyzed across the state, the true rhythm of that ancient instability remains only partially understood. How much of Florida's deep past was shaped not by gradual change at all, but by moments of climate upheaval too sudden for the fossil record to fully capture? Follow the sediment record north and east now, away from the drowned river channels and dried lake basins already explored in this series, toward Florida's phosphate belt, a region of exposed limestone and mineral-rich earth where mining operations have, for over a century, inadvertently unearthed some of the state's strangest fossil treasures. It is here, among crushed shell and ancient riverbed deposits, that paleontologists have recovered the remains of something almost impossible to picture moving across Florida's landscape today. Birds built on a scale the modern world has entirely forgotten. Florida's fossil record preserves the remains of several extraordinary bird species that once shared the peninsula with mammoths, giant sloths, and the other Ice Age giants already explored throughout this series. Among the most striking is Titanus walleri, commonly known as the terror bird, a flightless predator standing well over 7 feet tall, with powerful legs built for speed, and a massive hooked beak capable of delivering devastating strikes. Fossil remains recovered from Florida sinkholes and phosphate deposits confirm that this formidable predator, part of a broader group of terror birds that originated in South America, made its way north into Florida sometime during the Pliocene, becoming, for a time, one of the peninsula's most fearsome hunters. The terror bird's presence in Florida is itself a small mystery worth pausing on. Most terror bird species remained confined to South America throughout their evolutionary history, and Titanus walleri represents one of the only confirmed instances of this predatory lineage successfully establishing itself in North America. Its arrival appears tied to the formation of the Isthmus of Panama, a land bridge that connected North and South America and allowed species from both continents to migrate across a barrier that had separated them for millions of years, an event researchers referred to as the Great American Biotic Interchange. That same exchange sent North American predators like early cats and dogs southward into territory they had never before occupied, reshaping ecosystems on both continents simultaneously. While countless species crossed in both directions during this period, few of South America's largest predators managed to establish lasting populations in the north, and fewer still managed to persist there for any meaningful stretch of time. The terror bird, remarkably, did both. But Titanus was not Florida's only giant Pleistocene bird, and it may not even be the strangest. Fossil deposits across the state have also yielded the remains of enormous vultures and condor-like birds, some with wingspans reaching well beyond anything found among modern North American species, alongside evidence of oversized cranes and other large-bodied birds adapted to Florida's wetland and grassland habitats. Together, these species paint a picture of an Ice Age skyline and landscape populated by birds on a scale almost entirely absent from the world today, scavengers and predators built to match the enormous mammals already explored throughout this series. Why did such a spectacular array of giant birds vanish from Florida, and largely from the fossil record altogether? The mainstream explanation follows patterns already familiar from earlier chapters. As Florida's Ice Age megafauna disappeared, the massive scavenger species dependent on their carcasses would have lost a crucial food source, their survival intimately tied to the very mammoths, ground sloths, and other giants already gone extinct by the same narrow window of time. For active predators like the terror bird, the disappearance of familiar prey species, combined with a shifting, increasingly forested landscape less suited to a fast-running ground predator, likely proved equally devastating. This explanation accounts for much of what researchers observe in the fossil record, but the terror bird's extinction timeline in Florida specifically remains less precisely understood than researchers would prefer. Some fossil evidence suggests Titanus may have persisted in Florida later than its South American relatives survived elsewhere, potentially overlapping with the earliest human populations to arrive on the peninsula, though the exact dating remains a subject of ongoing debate within the paleontological community, complicated by the difficulty of precisely dating fossils recovered from Florida's disturbed, waterlogged sinkhole deposits. If this overlap did occur, it raises a genuinely tantalizing question. Did Florida's earliest human inhabitants ever encounter this formidable predator directly? And if so, what role might that encounter have played in either species' fate? No confirmed archaeological evidence currently demonstrates direct interaction between early Floridians and the terror bird, a gap that may reflect either the rarity of such encounters or simply the limitations of a fossil record that has not yet produced the right site in the right condition. Researchers continue to search Florida's sinkholes and river deposits for evidence that might resolve this timeline more precisely, aware that a single well-preserved find could meaningfully shift current understanding of exactly when and under what circumstances Florida's terror birds disappeared for good. At the more speculative edges of this mystery, a handful of researchers have proposed that Florida's karst caves and deep sinkhole systems, largely unexplored compared to more accessible fossil sites, may still hold undiscovered remains capable of extending or complicating the current extinction timeline for the region's giant birds. This remains an open, largely unexplored possibility rather than an established finding, but it reflects a broader truth that has run throughout this entire series. Florida's underground and underwater spaces continue to hold fossil evidence that surface archaeology alone has never fully mapped. What is certain is that Florida's ancient skies and grasslands once hosted birds of a scale the modern world has entirely forgotten. Predators and scavengers built to match an ecosystem of giants that no longer exists. Somewhere within Florida's still unexplored sinkholes and cave systems, the final chapter of the terror bird's story may yet be waiting. What might still be found if the right cave were finally reached? That same phosphate-rich limestone, the exposed mineral earth that gave up the terror bird's bones, is not simply ancient riverbed sediment. Look closely at certain limestone formations across Florida, particularly in the older bedrock underlying much of the state, and a different kind of structure begins to emerge. The fossilized remains of coral, layered and compressed into stone. Evidence that long before Florida was a peninsula of rivers, lakes, and grassland at all, it was something else entirely. A reef. Millions of years before the Ice Age megafauna already explored throughout this series ever set foot on Florida soil, much of the peninsula sat submerged beneath a warm, shallow sea, its underlying limestone built layer upon layer by ancient coral colonies working across unimaginable stretches of time. Florida's very bedrock, the same porous karst foundation responsible for its sinkholes, springs, and vanishing rivers, is in large part a fossilized coral reef, compressed and hardened over millions of years into the solid stone that now underlies nearly the entire state. In a very literal sense, modern Florida is standing on the skeleton of a much older world. These ancient reef systems did not last forever. Geological evidence embedded within Florida's limestone reveals distinct periods of reef growth, interrupted by significant collapse, stretches of time when the thriving coral ecosystems that built so much of the peninsula's foundation appear to have died off suddenly, leaving behind exposed, eroded limestone before new coral growth eventually resumed, sometimes after a gap of unclear duration. This pattern repeats across multiple layers of Florida's geological history, evidence not of a single reef collapse, but of a landscape that experienced this cycle of growth and destruction more than once over its deep past. What could cause such widespread coral collapse across a system that, under the right conditions, is capable of building an entire state's bedrock? The mainstream explanation points to a combination of familiar environmental stressors, many of which echo forces already explored throughout this series. Sea level fluctuations, tied to the same glacial cycles responsible for reshaping Florida's coastline discussed earlier, would have periodically exposed shallow reef systems to open air, killing coral colonies that depend entirely on remaining submerged. Changes in water temperature, salinity, and sediment influx, potentially linked to the same abrupt climate shifts explored in a previous chapter, could have similarly disrupted the delicate conditions coral reefs require to survive, triggering die-offs capable of collapsing an entire reef ecosystem within a geologically short span of time. This explanation accounts for much of what the limestone record shows, but it leaves a harder question only partially answered. Because the timing of certain reef collapse layers, according to some researchers studying Florida's deep geological past, does not always align cleanly with the broader climate and sea level record reconstructed from other sources. Some collapse events appear to have occurred more abruptly than gradual sea level change alone would predict, prompting researchers to consider whether more localized or sudden events, currently difficult to detect within the ancient limestone record, may have played an underappreciated role in these ancient reef collapses. Some geologists have proposed sudden volcanic or tectonic activity within the wider Gulf and Caribbean region as a possible contributing factor, capable of altering water chemistry or triggering underwater landslides that could devastate a reef system far more quickly than climate change alone. Others point to the possibility of ancient algal blooms or localized oxygen depletion events, conditions that leave subtler geological traces and are consequently harder to confirm within limestone laid down millions of years ago. Neither explanation currently has definitive supporting evidence specific to Florida's reef collapses, and both remain active areas of ongoing geological investigation rather than settled conclusions. There is also a deeper, more unsettling question embedded within this ancient story, one that connects directly to nearly everything already explored throughout this series. If Florida's very foundation was built and periodically destroyed by cycles of reef collapse occurring over millions of years, long before any of the Ice Age megafauna or early human populations discussed elsewhere in this series ever existed, then the instability so often attributed to more recent climate shifts may in fact be a far older, more fundamental characteristic of the Florida Peninsula itself. Was the porous, unstable karst landscape responsible for so many of this series' other mysteries never a temporary ice age condition at all, but the inherited legacy of a reef system that has been collapsing and rebuilding itself for tens of millions of years? At the outer edges of current research, a small number of geologists have suggested that certain unusually deep or unusually structured limestone formations, recovered from below Florida's surface, may represent reef collapse events more sudden and catastrophic than anything currently documented in mainstream geological literature. Though the technical challenges of dating and interpreting deep limestone cores leave this hypothesis largely unconfirmed. Most researchers remain cautious about drawing firm conclusions from such limited, difficult-to-interpret evidence, and the standard gradual explanation remains the dominant scientific position. What is certain is that Florida itself is built upon collapse, layer after layer of a reef system that rose, thrived, and fell apart long before anything resembling the modern peninsula ever existed. Somewhere within the deepest limestone still buried beneath the state, the full record of exactly how and how many times that collapse occurred remains only partially understood. How much of Florida's deep instability was written into its very foundation long before the Ice Age ever began, long before European settlers ever cleared land with axe and torch, and long before written record could capture what Florida's landscape once looked like. Fire was already shaping this peninsula in ways still being pieced together today. Buried within the same layered sediment already explored throughout this series, the lake basins, the sinkholes, the ancient reef limestone, lies a parallel record, written not in bone or coral, but in ash. Charcoal fragments, preserved within sediment cores extracted from lakes and wetlands across Florida, provide researchers with a remarkably detailed record of ancient wildfire activity stretching back tens of thousands of years. By examining the frequency, thickness, and composition of these charcoal layers, scientists can reconstruct patterns of fire across the Florida peninsula long before any human record existed to describe them, identifying periods of intense, repeated burning, alongside quieter stretches when fire activity appears to have been minimal or entirely absent. What emerges from this ash-layered record is a landscape shaped as profoundly by fire as by water, a peninsula whose ecosystems in many cases appear to have depended on regular burning to maintain the very grasslands and open pine forests that supported so much of the megafauna already explored in this series. For much of Florida's Ice Age history, fire appears to have played this relatively balanced, ecologically necessary role. Lightning-ignited wildfires, a natural and expected feature of Florida's subtropical climate, would have periodically cleared dense underbrush, encouraged the growth of fire-adapted plant species, and helped maintain the open grassland habitats that species like the ancient horses and camels already discussed in this series depended on for grazing. This kind of fire regime, researchers believe, was not destructive in any lasting sense, but rather a routine, cyclical force that shaped and sustained Florida's prehistoric ecosystems for millennia. But buried within certain sediment layers, researchers have identified periods of dramatically increased fire activity, charcoal accumulations far denser and more frequent than what natural lightning ignition patterns alone would typically produce. These intensified burning periods appear at multiple points throughout Florida's deep past, and their timing raises a genuinely compelling question already familiar by this point in the series. Do these spikes in ancient wildfire activity correspond to the arrival and expansion of early human populations across the peninsula? The mainstream explanation increasingly points toward exactly this connection. Indigenous fire use, a well-documented practice among many pre-colonial societies across North America, involved the deliberate, controlled burning of landscape to encourage new plant growth, improve hunting conditions, and manage vegetation in ways beneficial to human survival. Ethnographic and archaeological evidence from later Native American communities across the Southeast describes similar burning practices used to clear travel corridors, drive game toward waiting hunters, and encourage the growth of specific food-bearing plants, practices that, if they extend back into the deeper past already explored in this series, would represent a remarkably early example of intentional environmental management. If early Floridians employed comparable techniques, the increased charcoal deposits found in certain sediment layers may represent some of the earliest physical evidence of intentional landscape management on the peninsula, a subtle but significant sign of humans actively shaping their environment rather than simply surviving within it. This explanation, while compelling, leaves several details only partially resolved. Distinguishing between naturally ignited wildfire and deliberate, human-set fire within an ancient charcoal record is technically difficult, and researchers continue to debate precisely how much of Florida's ancient fire activity can be confidently attributed to human intervention versus natural causes alone. Some charcoal spikes align closely enough with the known periods of early human expansion to suggest a strong connection. Others occur in sediment layers with insufficient additional evidence to draw firm conclusions either way. There is a further layer of complexity worth considering, one that connects directly to the broader instability already explored throughout much of this series. Florida's Mega-Droughts, discussed several chapters ago, would have created conditions extraordinarily favorable to wildfire, dry vegetation and reduced groundwater combining to produce landscapes primed to burn far more intensely than during wetter periods. Some researchers have proposed that certain ancient fire spikes may represent a compounding effect. Drought-stressed landscapes ignited by either natural lightning or early human activity, producing fires more severe and far-reaching than either factor could have caused on its own, and potentially accelerating the very vegetation shifts already identified within Florida's pollen record. Untangling exactly how much of this ancient fire record reflects climate, human activity, or some combination of both remains an active and unresolved area of ongoing research. At the more speculative edges of this mystery, a small number of researchers have proposed that some of Florida's most dramatic ancient fire events may correspond to still unexplained ecological disruptions, periods when unusually severe burning appears to align with broader shifts in vegetation, animal populations, or sediment deposition that current models do not yet fully explain. This remains a minority position, largely unconfirmed by additional evidence, and most researchers continue to favor explanations rooted in the combination of drought, natural ignition, and early human land management already discussed. Still, the precise relationship between Florida's earliest human inhabitants and the fires that periodically reshaped their landscape remains, in certain sediment layers, frustratingly difficult to fully disentangle. What is certain is that fire, every bit as much as water, helped shape the Florida landscape long before recorded history began, leaving behind a charred, layered record that continues to raise as many questions as it answers. Somewhere within the ash still preserved beneath Florida's lakes and wetlands, the full story of exactly how, and by whose hand, this ancient landscape burned remains only partially told. How much of Florida's deep past was written not in bone or stone, but in smoke,